All right, so now we have Cheryl. Hello, Cheryl. Cheryl Biswas, the infamous encrypted. How are you?
I'm great. Thank
Yeah.
you for having me. I hope this
No.
is good.
No, it's gonna be fantastic. Following Kai, it's always interesting.
No. Oh, that was great. But I think kudos for having Dave open it.
I know, Dave.
All the energy, all the laughs, just what I needed.
Yeah, I know, it's fantastic. But what do you think about, really quick before we go to start with you, what do you think of that result of that that Kai just shared with us, that 52 out of 1,000 phishing emails are successful? Holy crap.
See, that's why we need to have things like this, right? To really hit the point home. You think you know something, but when you hear the truth,
it hurts. It hurts because you're basically fighting a losing battle. Because you go back to Dave's presentation, which focused on the basics, right? Trust. And it was a lot of things on basics, which a lot of people in the industry, we forget about, and we like, it's not sexy, right? Work on your policies, work on your governance, and then implement the basics. You don't need to go crazy putting everything in there. And one of our friends here in common, Win Rims, was this morning in Twitter, he was mentioning something about, he said, based on a conversation with a friend, security solutions products most often don't work or need extensive customization workarounds to work in secure infrastructures. So again, Kai's presentation actually proves that point. We may have a whole bunch of solutions implemented, but they're not doing it because it's too difficult to implement. So go back to what Dave was saying, go back to the basics.
See, and just it's ground truth, right? And something else I love is there's this theme going through of trust.
Trust, exactly.
Both of them.
And now we're going to talk about trust, the rising risk of software supply chain attacks. That's an unreal topic, and it's I mean, it's modern. It's right now. It affects all of us. So you have I made you a co-host, so you can go ahead and click on share.
Okay, I'm going to share and then
select your screen.
Yeah, give me 1 sec. I will share, and then it should all be good. Hello, mouse cursor. Yes, it hasn't had enough coffee this morning.
I think Dave had enough for all of us.
Okay, so we've got that, and then I'm just going to set myself up, and I will launch this.
Okay, puppy. Go ahead. Let's see. Nice little baby Yoda there.
All right. Now this should be all good.
Voice the well. Beautiful. All right, I'll step away. Thank you, Cheryl.
Thanks, Ed. Okay. Good morning, everybody, and welcome. And this has been fantastic so far. I'm really, really happy to be here today and to be able to share my learning with all of you on software supply chain attacks, which I thought were fascinating before I got into this, but holy cow. So, like Ed said, I bring the knowledge, and I am super passionate about sharing what I've learned. So just a little tiny bit about me. Currently, I work as a threat intel specialist with TD Bank. So I'm going to give a shout out to my amazing team there. And you may know me from my work with the Diana Initiative. So just a very quick little spot, because they do amazing, wonderful work, and we're having a virtual conference again this year from July 16th through 17th. You can register on our website at dianainitiative.org. And again, a shout out and love to the wonderful team and the volunteers who helped to make this happen. So let me start with this. What a year it has been. Even before we got out of the gate, the tone was set. End of 2020. SolarWinds was truly unprecedented. And it's the kind of event that we talk about for decades. We build off of it, we learn from it. But the thing is, software supply chain attacks, they aren't something new. In fact, they've been around for years. And we've been watching that check engine light on our dashboards, but not really addressing the issues. So I'm here to tell you that there is a lot more at work than what we realize. Essentially, they are an abuse of trust, because this really is compromise right at the source. And it can create access points, dangerous access points, into the networks of those customers, as we saw demonstrated by the SolarWinds Orion attack. Thousands, tens of thousands of customers. And also, as we learned, nobody is untouchable. Everyone is a target. So Nick Weaver, who is a security researcher at the University of California's Berkeley International Computer Science Institute, had this to say. Supply chain attacks are scary because they are hard to deal with, but they make it clear that you are trusting a whole ecology. Just think about that, a whole ecology, right? You are trusting every vendor whose code is on your machine, and you're trusting every vendor's vendor, the third party of your third party, and so on. We are grappling with the growing sense of complexity in tech. And it's not just what corporations deploy in their own environments, but it's how they are incorporating third-party tech. It's integral to how we are growing and developing, the push for innovation. We continuously evolve. And as Windows Snyder had to say on this, the product assumes all the security risk of the components that it incorporates. There was a really cool podcast by Axiom featuring her and Senator, I forgot his name, sorry, but I recommend taking a quick listen because it addressed current issues really well. So let's talk then about who are behind these attacks and what are their motivations. Essentially, it is the purview of state-sponsored threat actors. And you can group them into two large categories. There's the Chinese cyber espionage groups. You may know them by name. They have a lot of names, but essentially the biggies are APT-10, APT-17, and APT-41, who do a lot of very interesting and nefarious things. And then, of course, no surprise, there are the Russian threat actors, all the bears. So China has actively targeted tech companies in Taiwan with supply chain attacks. There's more than I can report here. And the reason they do this is because they see them as major competition. And this is where what I do, threat intelligence, plays a key role, because we have to be watching the geopolitics of this all play out. And we need to be able to reach backwards for historical context on the actors and on their patterns of behavior. And we talk all the time in cybersecurity about the importance of watching patterns and the importance of context. Because the fact is, history repeats. And even more importantly, actions have consequences. So Ian Pratt, who is the global head of security for personal systems at HP, had something interesting to say, which was effectively that, as they've seen with the upstream supply chain attack against SolarWinds, organizations of all sizes need to be cognizant of the risk that they could be either a direct target or a stepping stone to gaining access to bigger targets. And I can remember back in 2016, 2017, when I was newer to the field, and there was talk about a trend known as island hopping. And this was being carried out by very interesting APT groups and nation state-backed actors. And it was a wonderful way to be able to just utilize individuals who were far less prominent in an organization's relationships to gain access through their weaknesses, because believe me, they had neither the resources or the people power to be able to adequately secure themselves. And with some hunting and poking, you could just make your way through and island hop right up to the juicy prize. So both cybercriminal and state-sponsored groups are targeting the technology industry. And we shouldn't be surprised because these companies are relied on by so many organizations as well as individuals. It's essential to our everyday lives. It's more than just the work we do. It's how we express ourselves. It's how we share our ideas. It's vital. It is critical. And attacks on tech companies can have very wide-ranging impact for that reason. And it will enable third-party compromise of enterprise-level customers by, of course, software supply chain attacks. And that brings me to this, and it's true. And we're talking about needing to be able to fundamentally reassess how we look at risk in terms of our relationships. So let's talk now about the importance of open source. If you're in development, and these days it's just an increasing field for obvious reasons, open source is a way of life, and it's how development gets done. Now, we're forging our way to great, exciting new places like artificial intelligence and machine learning, and everybody is on this mass exodus to cloud environments. All of this requires software, and software requires coding, and coding requires software package repositories. So as you can see, this is an example of software package repositories that have been victims of supply chain attacks. Now, it's really easy to just get code from various projects online, and then you incorporate that into other software. And that could be either open source or it could be proprietary. But here's the risk. Some of those open source projects are widely used, but they're not well maintained. Others have even been abandoned. And the problem with abandoned and neglected things is they're not getting security updates. They're not getting the love and care and attention to protect them, which will then protect the rest of us. So you may know some of these groups already. You may know of Node.js, Arch Linux, Ubuntu, Ruby Gems, PyPy, Python. These are huge repositories, and they've all been targeted, and they will continue to be targeted. And given how sophisticated these attacks get, and they are going to continue to grow in terms of sophistication, any project that is not putting in basic protections like code signing is putting themselves at real risk. And because we are using other people's technology, that's putting us at real risk. It's a trust issue. So that brings us here to CICD, which stands for continuous integration and continuous delivery. This is essential. This is part and parcel of what we're talking about today, because that CI/CD pipeline is a best practice for DevOps in order to deliver code change frequently and reliably. Great. And it's a coding philosophy. It's a set of practices to drive development teams to implement small changes and check in code to version control repositories on a frequent basis. Again, excellent. This is in line with things like agile, right? Making small, frequent changes. You're constantly checking back, and your iterations are smooth and they're real time and they're valuable. They're relevant. It's a consistent, automated way to build, package, and test applications. And that's all good, except remember the caveat that we are still using other people's technology. And mistakes will be made. Yes. So in July of 2020, there was a SonarCube misconfiguration. Now, SonarCube is an open source tool which is used for static code analysis, and it checks for bugs before deployment. This may sound familiar to something else that I'm going to talk about in a few minutes. This is used by a lot of people. It's an essential part of how the work gets done. And unfortunately, misconfigurations happen, but there are consequences from when they happen. And those consequences are exponential when you're part of a supply chain. So this quote comes from Sakar Sarakai from the McAfee blog about what happened to SonarCube from July of last year. And the next part of this to follow up on is the consequences. What did that code contain? What did they have access to? Hard-coded credentials. That ties into something else that we saw this year that I'm going to talk about, because with what can you do with those hard-coded credentials and other special things that you find in code, you can gain access to things that you're not supposed to gain access to. And that is why developers and unfortunately insecure development pipelines are ideal targets for both state-backed and well-resourced criminal groups. Yes, like I said. So now let's talk about several major software supply chain attacks from the not too distant past and lessons that perhaps went unlearned. You may not have heard of this. I learned a lot about it during doing this because it was just something I'd heard in passing. I didn't realize just how significant this was, but that's why getting to do this presentation and then share it with you is actually such a gift. So in 2009, Operation Aurora served as a wake-up call when Chinese state-sponsored group APT-17, we talked about those guys before, targeted Google and Adobe and other tech companies for their source code management systems to alter the source code. And if this is sounding kind of familiar, it should. Remember, history does repeat. So this led Google to implement zero trust and to track lateral movement better and to also implement better infrastructure. What's interesting is how Google was not really part of that massive hit during the SolarWinds Orion attack. And then there was NotPetya 2017. That was that was major. Essentially, it involved an elite Russian hacking team known as Sandworm. And there's a great book by Andy Greenberg about Sandworm, and I highly recommend you can read it. And they were part of the Russian GRU military intelligence service. So they compromised and they took over software updates of something known as Medoc. This was accounting software used throughout the Ukraine. It was mandatory. You didn't get to pick all your different packages. You used this every year to file your taxes. It was essential. Well, Sandworm knew that. And so they compromised it. They got in on the servers, and then they used those servers to distribute destructive malware. Destructive malware, think wiper malware. Think of what happened to Sony in 2014, or what happened to Saudi Aramco in 2012. Bricked, very bad. And that infected major companies like Maersk Shipping as unintended consequences. Those were not the targets. The costs of this amounted to $10 billion globally. It is fascinating, and if you get the chance to read up on it, you should. In January of 2019, there was a sophisticated supply chain attack discovered, and it was targeting ASUS's live update utility. ASUS is massive for manufacturing computers and laptops. I've bought one. A ton of people have bought them. And this is a pre-installed utility on most of those ASUS machines. And it was used to automatically update certain components like the BIOS, the UEFI, the drivers and applications. It's the stuff that when you are an end user, you don't want to have to worry about. This is convenience. This is wonderful. It's great until it's not great. And according to Gartner, in 2017, ASUS was considered the 5th largest PC vendor for the world. Well, that would make it a very attractive target for APT groups who perhaps wanted to take advantage of that user base. And no surprise, the group that was behind this attack was APT-17. Now, they were also behind an attack on something known as CCleaner. And this was a popular application that was used to clean up hard drives. And you've probably seen those ads, and you've probably talked to people who ask you about things like, should I get this because my hard drive doesn't seem to be working well and this says it'll clear up space? Yeah, it's that kind of a product. And again, they infected that. People downloaded it, trusting it to work, trusting it to make their computer better, when in fact it did the exact opposite. And they also delivered something known as ShadowPad. Now, this malware was used to infect enterprise networks via a product known as NetSarang. Now, NetSarang did something that was important for enterprises. It offered server management and security connectivity software. That sounds like something familiar, doesn't it? So, as we've seen, the attackers go after the source code. And in the case of SolarWinds, Microsoft said that the attackers gained access to some of the source code for Exchange, Azure, and Intune. Now, having that source code gives them an advantage because it lets the attackers comb through it and look for the undiscovered vulnerabilities, those 0 days that they can exploit first. And that's kind of why I brought up that SonarCube issue. That's why we need to be vigilant. And then they go after certificates. We've talked about certificate abuse through attacks for many years, but this plays a key role in so many of the attacks that I've talked about or will be talking about today. And I'm looking at APT-41 in particular. Those stolen code signing certificates allow them to evade detection and then to deliver malware payloads as coming from a legitimate or trusted source. And that's what APT-17 did with the ASUS Live update in order to infect those ASUS users. Now, 2 years ago, with the NPM, the Node.js attack, we saw developer accounts being targeted and build environments being compromised. And that's going to lead into our discussion on SolarWinds. Huge. December 14th. I can remember where I was. I can remember signing on the weekend. A lot of people, a lot of long hours. That was when the news hit. This is trusted network management and monitoring software. Who isn't using it? It's used by the government. It's used by the top of the top. It's used by Fortune 500s, the Fortune 40. It's used by Microsoft. It's used by FireEye. Okay? Everybody, anybody who's anybody. And nobody knew that anything was wrong. It's fascinating to hear Mandy and FireEye talk about how they actually discovered it. And kudos to the intrepid worker who saw it and reported it. Fabulous. And what's distinctive is the degree of stealth, the ability to conceal their actions, and the length of time it took for the discovery to happen. So this was an operation marked by the time and the precision used to do the recon, the sophistication to tailor it, and the patience required to just let it bear out. And then, well, they targeted and compromised the software build environment and the code signing infrastructure for Orion. We've done a lot of work, and the fascinating thing is that there was custom built software implanted and executed at key times during this chain of attack. They modified the source code to add a backdoor, and they signed it. They leveraged the existing software release management system, and they used stolen certs to laterally move through those chains of trust. We've seen this before, but what's distinctive here is the degree of stealth and the ability they had to conceal their actions. And again, the time they took, which led out to be the time it took to be discovered. This was an operation marked by its OPSEC, its precision, its sophistication. Now, this attack, dependency confusion, has some pretty scary potential. It's a supply chain substitution attack when a software installer script is tricked into pulling a malicious code file from a public repository instead of getting the intended file that has the same name from a safe internal repository. Ah, tricky, huh? Yes, yes. And targeted companies included Apple, Microsoft, Tesla. There were about 32 of them. And it was initially presented by a security researcher to execute unauthorized code inside their networks and then demonstrate how this worked, because they were worried and they wanted to prove it without causing a problem. Unfortunately, somebody caught on and other companies were targeted in March, including Amazon, Slack, Lyft, and Zillow. You may not have heard of this. That's why I want you to, because we know attackers are targeting developers and they're targeting those shared sites, the repositories where code is uploaded for use by others. So in March of 2021, a new malware variant was observed, and it was targeting iOS developers in a supply chain attack to install a backdoor on the developer's computer. So Xcode Spy is a malicious project, and it will affect the free application development environment. That's not what it's intended to be, right? This is supposed to be trusted sharing. And it threatens that accepted behavioral practice among developers to share their coding projects to reduce the workload, to work more efficiently. And the threat actors are abusing this norm and using a legitimate development environment to fool the victims into adding an online project to their application. And that project will then compromise their system in this software supply chain attack. You probably heard of Codeckov because a lot of people got sideswiped by this. So this is an online platform used for hosting code testing reports and statistics. Yeah, like something else we talked about. And it provides developers with the tools they need to help them quantify how much source code gets executed during testing. Great. And this serves over 29,000 customers globally. A lot of them are enterprise customers, right? And this includes GoDaddy, Atlassian, Royal Bank of Canada, Procter & Gamble. The impact of this compromise went beyond that to thousands of public development projects. And these included Ansible, Kubernetes, PyTest. And it also impacted Rapid7, Twilio, and an e-commerce platform known as Mercari. That's a lot of fallout from this. The attackers had leveraged an error in the process, which creates Codecov's Docker image. And so that's what allowed for them to go in and, you've heard this one before, extract credentials, because there were credentials in what was being uploaded, to protect the modification of that bash uploader script. And this happens to be a tool, the bash uploader script, used by the customers in order to send code coverage reports to the platform. There wasn't supposed to be anything wrong with this, and this script was supposed to allow them to send what they needed up there for evaluation. Well, the attackers were able to now insert themselves into that process, and from there, they could find the credentials, they could find tokens, they could find keys, all kinds of security things that they shouldn't have access to, pass through Codecov's continuous integration environment. And with those, well, we know what happens next. Access to services, data stores, information, etc. What do we do? Well, Here are some good fundamentals that we need. We know code signing is essential. It's not perfect. We have to pay attention to it. Build in security by default. Make it a philosophy. Ensure that it gets done. Prompt communication. If something's wrong, get the news out there responsibly and as fast as possible so that we can take action. Work on better policies, processes, procedures, and international norms. Yes, as a result of SolarWinds and ransomware, there has been a significant executive order issued, and that's something else that we can look at. There's also recently been an announcement of something called SIG which I won't get into here, but people are creatively approaching this with solutions, and I'm encouraged by that. Now, Eric Shan of Symantec, who was integral in helping to investigate and decode something called Stuxnet, likens this to finding a needle in a haystack, having the right security telemetry and visibility at the right control points in your organization. I think both Kai and Dave hit on, when it's hard, it doesn't get done. And unfortunately, this sounds pretty hard, but we still need to do it. We have to find the way to do it. So yay, new executive order, a great starting point. But the picture is far bigger than we realize. So I'm going to end off with this. I love podcasts, and one of my favorites happens to be Risky Business. They had an excellent segment about Operation Aurora, and it featured Mark Rogers from Okta, whom I've referenced a few times in here, and I'm going to end with him as well. So if you can gain a position of trust, you can exploit it. And think service or non-person IDs. There are a lot of those, especially in our Windows-dominated enterprise environments. These are accounts that nobody really scrutinizes. They make a lot of noise, but they have enough privilege to leverage. They can do e-discovery, and they can find all the stuff you need to do an attack. Your chain is only as good as its weakest link. And there are more ways to abuse the chain of trust than people realize. And with that, thank you so very, very much. It was an honor.
Thank you, Cheryl. Wow, that's a lot of stuff there that you share with us. Some good stuff. Yes, really quick, going back to that 2009 Aurora attack. Remember the RSA attack around that time frame when, again, the code was stolen from them. There's a good article on Wired that just came out not too long ago that tells the story 10 years later, that now they can talk about exactly what happened when they stole the code. So take a look at it. And also, you spoke about digital certificates. Remember DigiNotar? That
yes.
People forget about that. We no longer have it. So it has happened. They did steal. They did hack a certificate authority. So
you know what? There is an excellent episode on Darknet Diaries about DigiNotar.
Yes, I remember. It's fantastic. It's
tasty
fantastic.
Stuff.
Yeah, but Cheryl, thank you so much. Appreciate it. Hey, we have a